Okay, today we're going to be taking a look at the total distance traveled. So all the examples from our homework today will be about that. The first example we're going to look at is an example where we go right 20, left 10, and then right 20 again. We kind of have a little bit of a drawing here of what's happening. And you notice that if we start at 0, and we go right 20, left 10, and right 20, we will end up at 30. So this is during a 10-second time interval. So t goes from 0 to 10. And so you can see that we are 30 units away from where we started 10 seconds ago. So we would say that the displacement was 30. And that's because this plus 10 cancels with this minus 10. Now what we are going to be focusing on today is the total distance traveled. So you'll see these absolute values on the velocity. So what that's going to do is that's going to make this negative 10 right here change to a positive 10. So if we change this negative 10 to a positive 10, then we add up all the pieces, we're going to end up with 50. So 50 would be the total distance that's traveled. Let's go ahead and take a look at our second example. You might recognize this picture right here. This is from an earlier example that we worked on. There was some kind of a squirrel traveling right, then left, then right. This is a graph of the velocity of the squirrel at any time t. And the time interval went from 0 to 18. So you can see that during the first 7 units of time, the squirrel traveled 140 units to the right. And then from t equals 7 to t equals 15, the squirrel is traveling left, a total of 50 units. And then from t equals 15 to t equals 18, the squirrel travels 25 more units to the right. Now for the displacement, you would get 115. Because from t equals 0 to t equals 18, your position would be 115 units further to the right compared to where the squirrel was when he started when t was 0. But if we wanted to get the total distance traveled, then the distance that the squirrel traveled to the left is still a distance that the squirrel traveled. So we still want to account for that. So we're going to make that a positive 50 instead of a negative 50. And we would get for the total distance traveled 215. Now, if we had the actual function instead of a graph, and we knew that the squirrel was traveling left from t equals 9 to t equals 15, what we could do is we know that that's going to come out negative for the integral, so we could put an additional negative in front of it, and that will change the negative 50 into a positive 50. So that's one way of dealing with an integral where your area comes out negative, and we want total distance traveled, so we want that amount to be positive. So you can make the integral positive by putting an additional negative in front of it. Okay, now we're going to do an actual example. This is one of the examples from our homework. We have this velocity function right here, and I went ahead and drew the graph of it. You'll notice that it does give us a starting position when t is 0. We're starting on the x-axis at x equals 1. We don't really need that for what we're doing in this question. So that's just extra information that might be used for part B or part C or something like that. What they want us to find out is what is the total distance traveled by the particle from t equals 0 to t equals 3. And I went ahead and graphed the velocity function so you can conceptualize it a little bit better. You can see the velocity is negative until you get to t equals a. And the a is actually 2.506, and there's a bunch more decimals after that. You can get that value just by solving where the velocity is equal to 0. And I would do it from 0 to 3 because this is a trig function, and it probably has an infinite number of spots where the velocity is going to equal 0. But again, we're looking for the total distance that's traveled. So there's 2 ways you could do it. The quick way is to put absolute value around your velocity. And that would make all of these negative y values change into positive y values. If you do that, make sure your absolute value is inside of the integral, not on the outside. And typing that in your graphing calculator, you're probably going to get 4.3338. And I prefer just to truncate it, so I would write it as 4.333. That would be the total distance that the particle traveled during the time interval from 0 to 3. Now, sometimes the AP test gives you a function that your calculator has trouble doing the calculation for. So you might not be able to do this calculation with your calculator because sometimes the AP test gives you a really tough function. So what you're going to have to do is break it into two integrals. For the first integral that goes from 0 to a, we know that the velocity is negative. So when we do the integral, we're going to get a negative number. So you're going to have to put an additional negative in front of it to make that entire amount positive. For our second integral that goes from a to 3, we already know it's positive. So that's going to be an easy one. You can just leave that alone. And we want to add these two values together. And if you add these two values together, you will get the same final answer. You're going to get 4.3338. Again, one of the most important things was to find where our velocity was equal to 0. And then we figured out, oh, our velocity was negative to the left of that, and our velocity was positive to the right of that. So for the blue shaded region, we didn't have to do anything because that integral was going to come out positive no matter what. But for the green shaded region, we knew that entire area was negative. It was all below the t-axis. So to make it a positive amount, we had to put an additional negative in front of it. So that's a little bit tricky. All right, that should be enough to go ahead and try some of our homework examples.